Hello. Can everyone hear me? In the back? far away at the back. Hi guys, welcome to our first Birmingham Meetup of the year. Thank you all for coming on this beautiful day. Look, firstly, I want to say a big thank you to BJSS, not only for the event space, for co-organising as well, and also for giving us two great speakers. So a big thank you to BJSS. A lot of new faces, right? So just a quick intro, nothing crazy. So my name is Vitas, and that's Ben, waving. So we're the co-founders of the DevOps Society, and those that have been to our meetups before, we do this quite regularly. And we've got a really good turnout for Birmingham, something we're trying to push, being from Birmingham myself. So yeah, it's nice to see a lot of faces for a Birmingham meetup. Alongside our meetup side of things, me and Ben are co-founders of a DevOps and Cloud recruitment agency. So if anyone needs any advice or just wants to have a chat about the market or just anything DevOps related, we're more than happy to have chats with anyone. So pull me and Ben to the side, and yeah, whenever later on, and we can have a chat. Yeah, we'll get going. So we got Jake first and Matt after. So we've got some good talks, but yeah, we'll get started. Jake?
So, hello everyone, I'm Jake. I'm a platform engineer at BJSS. I've been here about 3.5 years, and most of that time I've been working on data projects, primarily those with Databricks, for better or for worse. So today I'm going to tell you a bit about the journey we've gone on with Databricks Unity Catalog on the data platform I work on, and kind of give you a bit of an overview of Databricks itself and Unity Catalog. So let's start a bit about where the platforms come from, to talk about then where it goes. So there were quite a few challenges within the organisation that I've been working for that we were looking to solve. The primary of those was the siloing of data. So it's a government organisation where most of our data is held by third parties. It's loads of different consultancies, contractors and different firms have all of the data, and it's really difficult for anyone to get any value from it. You'll find projects are often spun up and they're trying to connect to the same sources over and over again. And there's just this repeatability that's just wasting the time and money of the teams that we have. A lot of this data is also unreliable. One of the big challenges that we face is the fact that data quality wasn't written into any of the contracts with these third parties. And this means we often have poor data models that don't match the data, things like Swagger docs that are completely out of date, and just poor quality data in general, that missing records, and things that don't match. Then on another side, there's a distinct lack of software and tooling in this organisation. We have a great story where we had some analysts that were using Data Studio to query some data, and all of a sudden one day the software disappeared off the laptops, and they'd spend 3 to 4 weeks fighting with IT to get it back, which was just a complete waste of time that frustrated everyone involved. And then on the other side, platform-wise, there's kind of a lack of expertise around platforms and building platforms in the organisation. So you'll often find they have to bring in consultancies and third parties to build platforms for them. They're often repeating the same things over and over again for different parts of the organisation. So our journey starts in November of 2019 when BJSS was initially commissioned to build a data platform. 9 months later, data platform DAS, as we call it, Data as a Service, was born, and we had 3 data sets live in the platform. And this is kind of what the platform looked like. So Data Factory was the main orchestration tool, it's all in Azure, and Databricks was used for our ETL workloads and everything data. So primarily data engineers working with Python to process data and build pipelines. We followed a quite standard raw ODS curated model for the data. This is the same as the medallion architecture, if you know, bronze, silver and gold. So raw is your raw data, ODS or operational data store is kind of your cleaned and tidy data, and then curated is where you're starting to build out tables for actual use and consumption. Alongside this, we had what was signups at the time, not signups at the time, data warehouse at the time, signups now, which was our database where there were specific consumption tables built for use cases. And then we have a range of users and teams using tools like Power BI to directly connect to query data, as as well as things like Databricks and FME flow, teams actually trying to build applications and get value out of the data themselves, plus a few other very unique use cases, queries via API, or things like geospatial data in a Postgres database. And the focus really for the first 2 years was, let's get more data into this platform so that people can use it, the data is centralized, and we can get value. And you might say at this point, we've solved 2 of those problems. We've got a central place for all the data that people can come and connect to, so the data is no longer siloed, and we're building our own data models, we're cleaning the data as it comes into the platform, so things are looking good. But this really raised another issue that comes out of the other 2, which was actually difficult getting value from the data. While we built the platform itself, people were still struggling to query the platform and access the platform. It didn't really solve the problems people were having with not having software to query the platform or not having the workspaces. So we have a great story where we had a MLOps team, and they built out a POC Databricks workspace so they could use our data and some other data sources. And over the 2 years that existed, 10 of the workspaces were spun up. What was meant to initially be for a POC was then being used by teams all across the organization to try and productionize their workloads. And we had a team that were planning on building models and doing data science that ended up managing the platform. And it was a waste of their time, but also for everyone else, they didn't have the platform they needed and all the tooling they needed to do what they wanted. So it just wasn't meeting our goals, and we spent all this time building a platform that people couldn't really get value out of. And so then in 2023 is when the real shift happened towards making improvements to the platform and making the platform more accessible. And that's when what we call the product and platform team was established, which is the team that I've been working on. And one of our primary focuses was enabling Unity Catalog to improve the state of the platform. So let's start with a bit about what actually is Databricks and Unity Catalog. So if you've never used Databricks before, they call it data ecosystem, the data lakehouse platform. It's a big tool that's designed for all of your data needs. We have dashboarding, we have machine learning use cases and ways to publish models. There's data warehousing, one big thing they push is streaming, as well as anything you need for data engineering. It really is all just built on your cloud data lakes and storage accounts. On top of this, the big thing that Databricks themselves are trying to push is Delta Lake. So Delta Lake is actually a file format known as Delta Parquet, and this is something that adds kind of reliability and performance by adding a transaction log to all of your data. So instead of doing, say, bulk loads of data, you're doing Delta loads every day, and this massively improves performance and is great for things like streaming. On top of this, we have Unity Catalog, which is all around governance and central management, and this is what really forms Databricks, and I'll show you more exciting stuff actually within Databricks in a minute. The centre really, and the difference that Databricks has made over the past few years, is this Unity Catalog. So before Unity Catalog, we were using Databricks for our ETL workloads. Every single Databricks workspace is independent. Databricks has its own group management system that's separate to Entra. And so in every single workspace, we're having to sync all of our groups, manage our access control, and populate data into the workspace, which is just not efficient at all, and is a bit of a waste of time. So Databricks introduced Unity Catalog, and it's this kind of central top-level account layer that centralizes user management. So instead of syncing users to every workspace, you have a central account that you use, and then you federate these out, as well as things like access control being central, and this meta store, which is for accessing your data, is also central, so you can have centralized data management. And the way that it's kind of represented with the meta store at the center, within this you have quite a few different things. You have things like storage credentials and external locations, so that's how you actually connect to your data sources and your cloud data lakes. You have things like Delta shares and recipients, which are meant for really easily sharing data to other workspaces. And you also have easy-to-use things like connections that allow you to connect to all sorts of third-party services, from pulling data from Snowflake directly to Databricks, or connectors for querying it with Power BI. But at the centre of this, in kind of the data world, is the catalog. Catalogs are just designed as a way to organise your data. So, for example, we have raw ODS and curated catalogs. You may decide to divide this by business units or environments. It depends on your use cases. Within these catalogs, you have schemas, which are basically your databases. And if we go within the schemas, as you kind of expect, you have tables and views, just like in the database. You have volumes, which allow you to directly interact with cloud object storage. These can contain your machine learning models, and then functions as well for things like color masking. And this all comes together when you're actually trying to use Databricks as a user. You have some form of compute, which is either a standard Databricks cluster or a SQL endpoint. And you're either using SQL or any of the languages that support, so Python, Scala, to query the data. The access control is centralized in Unity Catalog, so instead of managing everyone's connections to the cloud object storage, you're just doing it directly in Databricks, and it's all under the hood, everything else. And they're querying managed tables, which Databricks manages, external tables, which connect directly to your cloud storage, or, as we mentioned with volumes, the actual files. So let's actually have a look at Databricks. So typically Databricks itself, you'll have a workspace for each thing you're doing. So here in Azure, I have a workspace, a storage account, and what's called an access connector for Databricks. The access connector is just a managed identity to grab permissions, and that's what allows me to have permissions over the storage account. But the heart of everything is really Databricks itself. So traditionally in Databricks, you have your workspace, and so this is my Databricks workspace. A lot going on at once, but functionally, if you look down the left-hand side, we've got different sections of our SQL workload. So SQL editor, you can save queries and run SQL queries as well as SQL warehouses. We have different data engineering things, so you build out jobs out of notebooks and tasks, like any kind of pipelining and templating language. And you also have your machine learning workload, so you can build your models. They have their own built-in tools for experimenting with them. All it uses MLflow, and then they also have serving so you can productionize and share your models. The heart really though, when you're working with Databricks, is notebooks. So here I have an example notebook, and within this I've set the language to Python, but there's interesting things you can do. So you can use what are called magic commands. So I can have this notebook and I can run SQL, I can run Scala and other languages all within one place. So here in the second cell I have a reference to a volume. So that volume is referencing a JSON file directly in cloud object storage. I'm loading that into a data frame, and then I'm going to write that out to a table. So following the model of the, you've got the catalog schema and then your tables under that. I've got a catalog called F1 for some F1 data. I've got my bronze layer, which is my schema, and then the table I've decided to create is driver details. So you can see here where I've done the df.show, it's printed out the table here, and you can see I've just got some data around F1 drivers, their numbers, their acronyms, and their team. But then, if I want to, as I mentioned, I could run some SQL here. So I've created that catalog called F1, and then I'm going to directly reference that volume with SQL to create a table from some CSV data, and it's as simple as running that. And that will load that CSV into a table within Databricks that's managed by Databricks, and we should hopefully see it in a second. But following on from, okay, so this is an example of our CSV data that Databricks has passed and loaded directly into a table. And so what Databricks does, I've got that CSV data, but it's loaded it into Databricks' storage. It's managed by Databricks, and this CSV is now actually in Delta format. By default, it will load everything that's managed by Databricks into Delta format, which brings all the performance enhancements and things that Databricks market it as. And then following kind of model I said of having, say, the medallion architecture of bronze, silver, and gold, or raw radius creators as we have in our project, I'm here going to join two of the tables together, and I've just said this is a gold aggregation that I've created, and this is simply just going to create a table in the gold layer, combining some of the details from the two tables above, and it should hopefully provide, there we go, both of our data sets had driver name, only one of them had, both of them had the driver ID, one of them had the name, the other one has lap times, and we've just created a really simple aggregation here of mapping the lap times to the drivers and their teams based on the data. And then if I go into the catalog, this is where the meta store really resides in your workspace. And under here you can see I've got my F1 catalog, I've got my source data here, which has the volume, and you can actually see the volume. I've got 2 files, and I can show you that in Cloud Object Storage. If I go in the storage browser, hopefully. Within my container, I've got this volume I've made here, so the files are underlying in Cloud Object Storage, but you're able to manipulate them to Databricks, and I can easily upload them here. So users there can do anything that they want within Databricks, and it can cover everything that they need in a lot of different use cases, and it can be really powerful to use, especially the thing we've found with users with less experience. It provides quite a safe playground for them to play around with and test things in, but also do everything that they need. So let's talk a bit about the key things we had to do when implementing Databricks. One of the big things I mentioned was to do with groups. So Databricks has its own groups, and we had to sync our groups into Databricks. Databricks themselves provide an enterprise application with Microsoft, so there's SCIM or System Cross-Domain Identity Management, so that we can take the groups we already have in Entra and sync them directly into Databricks. This means we're not having to manage groups in 2 places, and everything that's in Entra can then be in Databricks. But there's of course a few problems with this. An example of how we currently manage, or have always managed our data lake, is we have a read group and a write group for each of our data sets, and from this we build out data analyst and data scientist groups with mapped permissions in different places. Sadly, these are nested groups, and that's not supported by the enterprise application, and it also can't support service principals. So we have service principals to write our data, they're in the write group, and so this was a bit of a no-go for us. So we had to build a Python package using the Databricks API. I can show you quickly. Databricks API, there's tons of documentation basically covering everything with Databricks for AWS, GCP, and Azure, both the workspace and account level that I get onto. And so we've had to build out our own package calling the different groups and managing the different use cases we have. There's been quite a lot of issues around that with how you kind of manage things like nested groups. We've had a lot of issues with kind of identities that are differently mapped, but we've built out a Python package that uses the API to sync those users. We then had to start looking at actually deploying things. So you saw I was running on a cluster. How do we deploy a cluster to Databricks? How do we deploy our models? How do we manage secrets? And so we already had a Python package for calling SCIM and managing groups. There wasn't a lot of appetite at the time for Terraform, so your options when deploying things to Databricks are the API, the CLI, or Terraform. We've had bad experiences with the CLI, poor documentation, commands not working as they're documented, and just general issues with versions. Not a lot of appetite from the client to move to Terraform. We've currently just done a migration for ARM to Bicep, and there wasn't a lot of expertise on the teams, so they were really scared of introducing another language to the platform. So we decided we'd do it with Python. The way we did this again, calling the API, we built out a generic API package and then use something called Ginger, which allows us to have YAML templates which we can substitute environment variables into. So the example in the middle is building out a policy. A policy is how you can manage what clusters people can access. So what size of cluster, what software it can have installed, how many works it can have, and that's just an example there. And then as part of this, we built out restructured text to go with all of them, which then allowed us to convert our documentation to Markdown, and it could be published to the wiki using Sphinx. And we'll come a bit back to deploying things in platform later under the challenges. The next step was around data. So we already had data in our data lakes. How do we actually get that into Databricks? And that's through these external tables that directly reference the data that's in there. But how do we do this? So we built another Python package. That's where a lot of the team's expertise lies, especially our data engineers, called DD Components Metastore. And this was basically a wrapper around the Databricks SQL connector. Again, we built YAML-driven templates that would allow us to deploy SQL both inline and from files, but also we have our own data engineering components. That's a metadata-driven framework. So we expanded this to use that metadata to deploy those schemas and tables into Databricks. So we already have CI/CD pipelines we were using, just another stage in there that would take the data we already had in the data lake, bring that into Databricks for users to access. Now, of course, been plenty of challenges along the way. The one I may have alluded to slightly was our decision to use Python to deploy everything within Databricks. At the time, there wasn't the drive to do it, but the more and more I started writing API calls in Python instead of using Terraform, the more frustrated I got. And we had some great instances where the API schema would change without the version updating that just broke our code. And it was completely frustrating having to make updates and build out all of this code when I knew a solution was right there. So it just took one frustrated night to start doing some of my own Terraform for Databricks and start proving how much easier it was. And then the nail that really sold it to a client was spending an afternoon teaching a delivery manager Terraform. And through this, and kind of selling them the difference of spending hours writing out our Python code and then having to do YAML files that we have to maintain, to really simple deploying all of it with really well documented Terraform was great. And that's actually one of the journeys we're going on at the moment, is introducing things we don't have in Terraform and where we can, replacing these components. But yeah, all it took really was getting frustrated, trying it out one night, proving out and building some pipelines to prove how we'd actually do it and how we could productionize it, and then teaching a delivery manager and proving that anyone could do it. One of the other big things that Databricks are pushing is serverless compute. So you can have kind of your bog standard clusters, and everyone hates these in some ways because it takes 5 to 10 minutes to spin up every time. And this just means you're sat there waiting for your jobs to run a lot of the time, depending on what you're doing. But there are some kind of big issues that we faced with this. So they enabled something called serverless for notebooks, jobs, and Delta Live tables. You saw in my notebook I was able to just kickstart and run it straight away, and I was using serverless, which is really convenient. But anyone who is a user in a workspace, no matter their permissions, can use the serverless no matter what. And the serverless costing is really vague. There's no defined cost. They just say, we're going to manage the infrastructure, we'll scale it to the size that you need, and away you go. This means you could have hundreds of users in your workspace rather than using a predefined cost-specific cluster running huge workloads on serverless, and you're not going to know. The only way to restrict it is turning it off, which is a bit useless if you want to actually use it. Combined with this, serverless costs are doubling this month, which is going to be great if you've been using serverless workloads. And originally they weren't charging for networking. As of November they have been. And the kind of nail in the coffin for us that made it really frustrating is around how you manage the billing. So as we said, if we want to use serverless, we can't turn it off. And there are some use cases we have around column masking, where for that to work in compute, you have to have it enabled. It's actually how you manage that and manage billing. So you can set up billing alerts in Databricks in the account, but there's a 24-hour delay between billable events and when they actually appear in the tables, and then there's a delay before you get notified. So you never know, someone could spin up a huge workload, be running it for 24 hours before you even have any idea. We had a great example where we got an alert at the end of February for a test alert that actually went over budget in January. So we could have had something running for a month and a half, costing a bunch of money and not known about it. And there's no way to stop anything on cost. All you can do is set up notifications, and then you have to manage everything yourself. So you've just got dashboards and what have been so far ineffective budgets. And then going further down, serverless is open to the internet by default. So you can even go to the account and show there is these network policies, which are also still in preview. So they've thrown out serverless at the start of this year. And then in preview is the feature to actually lock that down from the internet. And as you can see, by default, full access to the internet. So if you're trying to use it in any kind of secure environment, it's probably a no-go. The only good news is that you can just restrict the default policy and force it for everything. Everything's locked down. But if you don't know about that, if you don't have access to the account, then you're done for. And so there's been quite a few frustrating things around that. But enough about frustrations. Where are we now, and what does our platform look like? So this is where we were at before. As of April last year, we'd onboarded our first data set to Unity Catalog, and as of January this year, we built out things called the Scratchpad, an innovation platform. So these are predefined Databricks workspaces that we are federating out to users in the business. So we have what's the Scratchpad, which is our consumption workspace that we're giving people in our kind of area of the business access to. and this provides them their own schema and compute that they can use to play around with the data in Unity Catalog. Don't have to worry about their local software, they don't have to worry about spinning up a project to create workspaces and tooling. They can access the data right there as long as they've got access within the groups and the process within the organisation. And it makes it much easier for them rather than having to figure out what they're doing. Give them a link to the workspace, they can start playing around in Python, Scala, SQL, and doing anything they want to the data. And then on the other side, we have the innovation platform, which is mostly around billing more than anything. We have a lot of teams that have a set CapEx budget, and so we don't really want them in our workspace because it's difficult to differentiate the costs in Databricks with the tagging. So we're spinning up predefined workspaces for teams, which have our own kind of billing solution that we've built out in Python, so that they have a place to work, it's connected to all of our data, and they can just have this and then follow a path to live that we're developing to actually get their data into production, rather than using a POC workspace that was spun up for a completely different use case. So it's been a really interesting exercise. So this is what the platform looked like before Databricks, and the eventual goal that we're still working towards is phasing out kind of direct connection to the data lake and also the data warehouse. Now people can query SQL directly in Databricks, and having these Databricks workspaces that we provide to make it really easy for the users. And if they're not using Databricks, there's tons of easy connectors. We have people connecting from Fawcett, from Power BI, and even in their own workspaces. And with things like Delta sharing, then you can also easily give access to people in other organisations to that data. So it's been really useful in kind of driving user usage, seeing loads of people actually start even getting the opportunity to play around data, which they didn't before. And it really helps people come with interesting use cases, test out use cases, and prove that we can deliver value. So now you could say that we've solved some of those problems. It's easier to get the value from data. Now we have the data centralized and a place to work. And we're building out those workspaces for them to access the software and tooling. And this actually helps with the fourth point, really. They actually have a place where they can play around and test out their code, test things and learn. And we even have teams that we're upskilling at the moment to kind of teach them data engineering best practice and actually get them more experience working with data. And that's that. Thank you very much. Are there any questions?
Questions?
If there aren't, feel free to reach out or ask anything of me.
Yeah. Thank you so much. I'm Najib. I'm a study engineer at Azure, so I'm happy to see like data stuff. I came here because I know DevOps is related to data, but it's good to see data stuff as well when we talk about DevOps. So I just want to understand if you take any consideration into like DevOps best practices like version control CI/CD as part of the platform.
So that answer.
I want to understand if you have like any DevOps practices implemented in terms of version controls to like Git and CI/CD pipelines. So why you do testing and continuous implementation?
Sorry, what was the question? I can't hear you properly. That's what.
Okay.
What was the question?
So it's about the use of kind of CI/CD and version control for deployment of workloads. So we've kind of had that in place for a long time where we work, and Databricks is quite good for supporting it. So the way we're actually pushing it out to data projects, as we've kind of said here, we're driving everyone towards using Databricks. So Databricks supports repos directly within Databricks, which is really useful for having that kind of central, easy to place. It's quite good for collaboration for people who say don't have tooling locally on the machine. And then from this, there's tools within Databricks like asset bundles, and you can also do things in Terraform to build out pipelines to deploy them. So typically, most people will work in a notebook within Databricks, so like the example I showed. And then from this, you actually build out typically jobs. And so here I've got a F1 load job. This is a really simple one. And all this is actually doing under the hood is triggering that notebook. So if I go to the task view, this is triggering that notebook. You can add a series of parameters and you can chain different notebooks together. That's kind of controlling within this. So the way we're implementing it at the moment is we have kind of those Scratchpad or development workspaces where people will build notebooks. We then pull them out of the workspace and have them version controlled in a repo. And from that, we have jobs that we deploy to the workspaces through the environments that let us run that code. So people can play around in their development environment, but then, as I say, you can actually export these jobs directly as templates, which makes it really easy, and then you deploy them back into Databricks. Hope that answered the question.
Yeah, no, it's fine, it's fine. There are just other we can also do it as well. You know, you could orchestrate it properly rather than using notebooks for the pipelines. You can use things like Kestra, I don't know if you know about it. So it's just for orchestration. So guys orchestrate to submit jobs. You're going to kill it, not just don't run it. You don't have to have your job running. It's not resources for clients. So there are a lot of we can talk about it in that session. Just to give some insight as well. How you can do it. Thank you.
Right, at the back.
Not really. Can you hear me?
Just about.
You spoke about asset bundles. I wanted to ask, have you tried using asset bundles before? The pros and cons to physically use asset bundles. What's your experience with asset bundles?
So we've used a few asset bundles and been playing around with them quite a bit. One of the reasons we quite like them is how simple they are. So it's actually been our focus of the teams that don't have much platform experience. It's quite easy to write those YAML-driven templates that Databricks provides for the bundles, and it's easy for them to play around and test it out with the CLI. So personally, where we kind of have a lot of our workloads, it's really easy to integrate the bundles. It's simple to deploy. You just validate, build and deploy your bundle in the pipeline, and it's been really good for things like this. You can directly export the workflows into kind of bundle templates, and you can use your predefined bundle templates, which has been very useful for us. We've also been playing around a bit more with doing it in Terraform, so bundles themselves are actually built on Terraform, and so you can do everything with kind of bundles in Terraform, which I think is great for platform engineers, but I think bundles typically, in my experience, of being a bit more user-friendly and easier for, say, a lot of people who say don't have experience with Terraform to get into deploying things and kind of productionizing things.
Thank you.
How do you handle scenarios where your data sets live in production environments, but in order to do the development, you have to have a control from utilise? So you have to have your code built, tested, and sanity checked before you can deploy it. But then the feedback loop isn't quite right because your manufactured data isn't represented in real data.
So this is one of the problems we actually had in our previous way of working, and one of the things we've been working on as part of Databricks. So, for example, our Scratchpad workspace, if you're say cleared and have access to the data, you can directly query and play around with the prod data, and people who that's their use cases of building, say, their dashboards, their notebooks against production data, to kind of make it much easier to build them without having to use synthetic data. But then all of those, when they're ready, go into version control and follow a path through our dev test and live environments, following kind of a standard productionization process, so that they're still being able to use the real data, which often makes it a lot easier, but we still then version control that and follow through that process, because we've had issues in the past with synthetic data. You then get it into prod and your workloads fail because there were unexpected nulls or something was wrong with the data model. So we're basically just providing a lot more access to prod data where we can, where people are cleared, and that's available.
So over there as well, would you? Yeah.
So this was really expensive. Are there any kind of entry level things that do similar stuff?
I guess really, you can run notebooks locally, but it won't be the same experience. Theoretically, serverless compute is cheap, but that's theoretically if you're wanting to use any kind of volume of data. It's difficult, but realistically, just playing around with, say, Jupyter notebooks or something locally is your best bet for starting to play around. But yeah, when it comes to Databricks, sadly there's no real cheap option. Using the static clusters, you can limit how much you're spending, but it's never that cheap. Not a great answer, but
Any other questions?
Does it still cost a lot if it's like even just basic, even if you've just got like one VM or something?
so it's not that expensive just running one VM. So I have an SDN subscription that has say I think £100 in Azure credit a month, and I can happily play around myself in Databricks,
Right.
and that's fine. There's just a lot of things to be aware of. So by default, I think the timeout on a cluster is 3 days. So if you run a cluster without checking, then you're instantly kind of in shit with how much it costs. And a lot of things like by default there's a lot of scaling. So they try default you're a lot of the time at 8 nodes, and it will scale whenever it thinks it can. So just being sensible with how you configure it. And these are the kind of things that caught us out when using Databricks really well. Not realising the hidden options, like you wouldn't think the timeout on a cluster would be an advanced option, but it is, and things like that. But yeah, the serverless workloads, things like SQL Warehouse now, times out, you can set it to time out after 2 minutes. And so spinning up the workspace itself is free. And Databricks as the workspace doesn't cost anything for the basic tier.
Right.
It's just then the underlying storage. The basic non-serverless compute runs on VMs as standard, and the serverless runs in Databricks as cloud that they build themselves.
The other question is back, you said you learned Terraform overnight. I heard that LLMs aren't very good at helping with that. Did you find anything that helped you?
I tried Terraform overnight, might be the better way of putting it. I gave it a go. I honestly, for me, it was just reading the documentation and going slowly through it. It helps. I understood everything under the hood in Databricks, so things can get quite complex. All of the different tabs in Databricks have all sorts of resources under them that interact in different ways. But for me, it was just going, okay, I want to deploy a storage account. How do I access that storage account in Databricks? I need, this is where it gets complex really, an access connector, which is a managed identity that has permissions. I need a storage credential to link that Azure resource into Databricks, and then an external location to have a certain path that that storage maps to. And then I can finally think about querying my data. But yeah, documentation really is being the best. And yeah, a lot of pitfalls with LLMs in my experience with things like this. One thing, especially a good example I think, is Databricks has its own built-in AI. So if you're using the SQL editor, there's a panel at the side that'll come up trying to suggest queries to you or how to fix your queries. The thing is, it will spit out any kind of variation of SQL it can think of, not just that valid in Databricks, which is really interesting for Databricks' own tool that should have been trained on their own data. But, always exciting and interesting, I think.